Imagine a tiny plastic tube saving a patient's life, cooling a spacecraft, or fueling a factory. How does it begin? Most people never think about this, but billions of meters of plastic tubing quietly keep our modern world running every single day. Behind every flexible tube hides a manufacturing process so precise that even a hair's thickness can determine success or failure. Inside these factories, raw plastic pellets transform into products trusted inside hospitals, airplanes, laboratories, and high-performance engines. But here's what nobody tells you. One invisible mistake during production can ruin thousands of meters before anyone notices. Engineers rely on sensors watching every second because tiny changes in heat or pressure can instantly change the tube forever. Think about this. The tube carrying drinking water and the one delivering life-saving medicine often begin almost exactly the same way. Yet different formulas, microscopic tolerances, and specialized testing decide whether each tube serves patients, machines, or entire cities. What happens next surprised even experienced engineers, because everything begins with tiny plastic pellets no larger than grains of rice. Our journey starts long before the factory floor, deep inside the global supply chain, where these remarkable materials first come to life. Before a single tube reaches a factory, its story begins thousands of miles away beneath ancient layers of rock and ocean floor. Many tubing grades begin with crude oil from Saudi Arabia, the United States, Canada, Brazil, and the United Arab Emirates. Some medical tubing starts from natural gas instead, producing exceptionally pure chemical building blocks with fewer unwanted contaminants. Inside giant petrochemical plants, hydrocarbons separate into ethylene and propylene, the essential molecules behind countless plastic products you use daily. Steam crackers heat feedstock above 850 degrees Celsius, or nearly 1,560 degrees Fahrenheit, breaking heavy molecules into valuable lightweight chemicals. Those purified chemicals become polymers like polyethylene, PVC, polyurethane, silicone, and nylon, each designed for completely different tubing applications. Medical-grade polymers often exceed 99.9% purity, removing microscopic contaminants that could compromise patient safety or sensitive laboratory equipment. Before shipment, molten plastic cools into tiny pellets, each weighing only fractions of a gram, but carrying extraordinary manufacturing precision. A single bulk container can carry over 1,000 kilograms, enough material to produce hundreds of thousands of meters of tubing. Rail cars, cargo ships, and heavy trucks move these pellets across continents, sometimes traveling more than 10,000 kilometers before reaching the factory. Most people never see another secret ingredient: precision additives that improve flexibility, UV resistance, color, flame resistance, or chemical durability. Factories measure these ingredients with astonishing accuracy, sometimes within 0.1%, guaranteeing every production batch performs exactly the same. But producing plastic also leaves an environmental footprint, pushing manufacturers toward recycled polymers, renewable feedstocks, and lower-emission production technologies. And this is where it gets truly extraordinary, because those ordinary-looking pellets are finally ready to enter the machines that reshape them forever. Now the real transformation begins. Thousands of polymer pellets rush into giant hoppers, feeding the extrusion line without stopping for hours. Powerful vacuum loaders continuously pull fresh pellets from storage silos, keeping production running 24 hours a day without interruption. Inside the extruder, a rotating steel screw spins between 30 and 120 revolutions per minute, pushing pellets steadily toward intense heat. Electric heating bands raise temperatures from 170 to 240 degrees Celsius, or 338 to 464 degrees Fahrenheit, depending on the polymer. Friction, pressure, and heat work together until every solid pellet melts into a smooth, honey-like stream of liquid polymer. Pressure now climbs beyond 200 bar, nearly 2,900 psi, forcing trapped airway before defects can ever form. Special vent ports remove moisture and microscopic gases because even tiny bubbles could weaken the finished tubing. Next comes the extrusion die, a precision machine steel tool that determines every tube's diameter, thickness, and internal opening. The glowing polymer emerges as a continuous tube, still soft enough to stretch, bend, or collapse without careful control. Workers constantly monitor diameter, while laser gauges measure accuracy within plus or minus 0.05 millimeters, correcting deviations instantly. What happens next surprises many visitors because this hot tube immediately enters freezing water instead of staying near the heat. The cooling bath stays between 15 and 25 degrees Celsius, rapidly solidifying plastic while preserving its perfectly round shape. Powerful vacuum calibration sleeves gently pull the tubing into its exact dimensions, creating perfectly smooth walls from end to end. Now the tubing looks finished, but this is only halfway through its journey, because every millimeter still demands perfect control. A synchronized haul-off machine grips the tube gently, pulling it forward at speeds reaching 120 meters every minute. If the puller moves even slightly too fast, the tube stretches thinner. Too slow, and its walls become dangerously thick. Powerful servo motors constantly adjust speed within milliseconds, keeping every dimension stable despite non-stop production around the clock. Some factories manufacture tubing with multiple layers, combining flexible interiors with rugged outer shells in one continuous operation. Medical tubing often forms in spotless cleanrooms where filtered air removes nearly every airborne particle before it reaches the product. Workers wear gloves, masks, and protective suits because even a fingerprint could contaminate certain life-saving medical products. Industrial tubing follows another path, receiving braided fibers or steel reinforcement for incredible strength under extreme working pressures. Braiding machines rotate at more than 250 revolutions per minute, weaving dozens of fibers into a remarkably strong protective structure. Next, precision cutters slice the endless tube into exact customer lengths, sometimes accurate within just half a millimeter. Other production lines skip, cutting completely, winding continuous tubing onto massive reels holding several kilometers of finished product. Every finished coil receives batch numbers, production dates, and traceability codes that identify every machine, operator, and material used. But here's where everything hangs in the balance, because one final inspection decides whether this tubing earns approval or heads straight for recycling. Now every meter faces its toughest challenge, because a factory trusts nothing until advanced technology proves every detail is correct. High-speed laser scanners measure diameter thousands of times every second, detecting variations smaller than the width of a human hair. Advanced AI vision cameras inspect every surface, instantly spotting scratches, bubbles, contamination, or color changes invisible to the human eye. Machine learning software compares every image against millions of reference samples, making inspection decisions in only a few milliseconds. Most factories reject fewer than 1% of production, yet even those pieces never reach customers or critical equipment. What happens next surprise even experienced engineers, because some tubes are deliberately pushed until they completely fail. Hydraulic systems raise pressure beyond 500 bar, or nearly 7,250 psi, confirming the strongest industrial tubing survives extreme conditions. Medical tubing bends through thousands of repeated cycles, proving it stays flexible without cracking, collapsing, or permanently changing shape. Climate chambers expose tubing to temperatures from -40 degrees up to 120 degrees Celsius, simulating years of harsh service. Factories also verify compliance with ISO 9001, ISO 13485, FDA requirements, and demanding customer-specific engineering standards. Yet one moment still belongs entirely to human experience, when skilled inspectors recognize subtle flaws that algorithms occasionally overlook. Only after passing every test does the tubing earn shipment, but its global story is far bigger than most people ever imagine. The journey doesn't end at the factory. Every year, manufacturers produce billions of meters of plastic tubing for industries worldwide. Industry analysts estimate the global plastic tubing market exceeds $30 billion, with demand climbing steadily every single year. China leads global production, followed by the United States, Germany, Japan, and India, supplying customers across nearly every continent. Together, those nations manufacture well over half the world's plastic tubing, powering healthcare, transportation, agriculture, construction, and advanced electronics. More than 1 million people worldwide help design, manufacture, inspect, transport, and recycle these remarkably versatile products every day. Did you know? The first flexible plastic tubing appeared commercially nearly a century ago, transforming countless industries almost overnight. Did you know? A single modern extrusion line can produce enough tubing in one day to stretch across an entire city. Did you know? Some specialized tubing costs hundreds of dollars per meter because precision matters more than the material itself. 50 years ago, most tubing relied on simple machinery. Today, artificial intelligence optimizes production faster than humans ever could. Over the next decade, smarter factories will recycle more material, waste less energy, and manufacture stronger tubing with lower emissions. Imagine this. Future tubing may even monitor pressure, temperature, or chemical flow using microscopic sensors built directly inside its walls. And after everything you've seen, one ordinary plastic tube suddenly becomes something extraordinary. But our journey still isn't quite finished. You've just witnessed an incredible journey hidden inside one of the world's most ordinary-looking products. From raw materials to remarkable precision, every smooth curve, every flexible wall, and every perfect dimension reflects thousands of engineering decisions working together with incredible precision. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world before reaching your hands. That's not just a product. That's a masterpiece of human engineering, built through science, innovation, precision, and relentless craftsmanship. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like next. Like this video, subscribe to the channel, and we'll see you inside the next factory.